So let's look at another example here. We have a random sample of 150 American adults, and each is asked if they believe that their children will have a better standard of living than they do. A total of 98 responded no. So we are going to verify interval requirements, construct a 98% confidence interval, and interpret the interval. So first of all, the confidence interval requirements, I brought those down from up above. The sample has to be randomly selected, and np prime and 1 minus p prime both have to be greater than or equal 5. So, well, it is a random sample here, so that requirement is satisfied. And p prime, let's compute that. So p prime is successes out of total, that's x out of n. We had a total of 150 people. And then 98 responded no, so that's what we're going to consider a success here. And 98 divided by 150 is 0.653 repeating. And so then our np prime is going to be 150 times that 0.653, 150 times 0.653 is 97.95, approximately 98, which is certainly greater than or equal 5. And then we want n times 1 minus p prime. So that's going to be 150 times 1 minus the 0.653. So 150, 1 minus 0.653, so about 52, and certainly greater than or equal 5. So both conditions are satisfied. Remember, the second condition is the normality condition. And now we can compute our confidence interval. So I brought that formula down from up above, and we've already got our p prime. We've already got n. N is 150, and we need that z value. Well, this is a 98% confidence interval, so our alpha is going to be 0.02. And notice 98%, that's not one of the three that's in the common confidence coefficient table. So we have to use inverse norm to get this one. So alpha over 2 is going to be 0.01. And then we want the z value with alpha over 2 to the right. So z 0.01, that means 1% to the right of that z value, so 99% to the left. So this is going to be inverse norm. And then the left area, 0.99. So second variables, inverse norm is number 3, 0.99. And we will paste it, 2.326. So now we've got all of our values here. Let's go ahead and compute our margin of error. So that is going to be the z value, 2.326, times square root p prime, 0.653, and then 1 minus p prime, 1 minus 0.653. And then we are dividing by our sample size n, which is the 150. So let's compute that on the calculator. So 2.326, we need a square root. I'm going to do alpha y equal enter to get a horizontal fraction. So now 0.653 in the numerator, times 1 minus 0.653, close up our parentheses, 150 in the denominator, 0.090 to 3 decimal places. And now we're going to find our lower bound, which is going to be p p prime minus the margin of error. So 0.653 minus our 0.09. So 0.563. And then the upper bound for our interval is p prime plus the margin of error. So that's going to be 0.653 and then plus 0.09. So 0.743. And then we want to interpret the interval. So we are 98% confident that the proportion of parents and this is going to be parents who believe that their kids are going to have not going to have a better standard of living. That proportion of parents is between the 0.563 and 0.743. And then that 98%, what that means is with repeated samples, of size 150, so large number of repeated samples, 98% of the confidence intervals that they generate will contain the population proportion. And we can check this on the calculator like we did before. So we want to go to the stat menu and then tests, and we want to scroll down until we get to a 1 proportion z interval. Our successes here are 98, our total trials are 150, and our confidence level is 0.98. So you want to enter those in, calculate, and we've got to 3 decimal places 563 to 744. 563, 743. Let's try that again. 653 plus 0.09. 0.653 plus 0.09. 743. Okay, so just a little bit of round off error there. So just some rounding. Yeah, 744. So we just had a little bit of round off. So 563 to 744 is what the calculator is giving. So 0.563, 0.74. I'll go ahead and leave the 3 here. 743, 744. So we just have some round off error in the last decimal place. And that's probably because we rounded here to 3 decimal places.